Alright, so in this screencast we are going to learn how to solve two vectors that are being added and both at an angle. So before we start, let's go ahead and draw out these vectors. So 3 meters north, 35 degrees west. What that is our baseline is north. And then from there, you're going to go 35 degrees west. So that way is west. This is the vector you're looking at. So there's 3 meters, and then that's going to be added by a 2 meter vector whose baseline is south, and it goes 25 degrees west. So from here, also goes 25 degrees west, and it's 2 meters long. Alright, now what we need to realize is that both of these vectors are made up of components, both y components and x components. So here, the y component of this vector, in order to get to this spot here, right there, in order to get to that spot, you have to start here, you have to go north some distance, right? And then from there you have to go west some distance. So here, the north distance that you do, that is known as your y component. The west distance is known as your x. Now here, same thing with this one, right? You have to go some degrees or some distance south. Okay, that is our y component, and some degrees west. That is our x component. Now, we have to use SOHCAHTOA to find the length of the x components and the length of the y components. And then from there, add the multitudes of those, and essentially, that will give us our results. Now let's figure out how to do that. Okay, so the way we do that is using SOHCAHTOA. So I'm going to redraw these triangles, right, or these vectors. So there's my north component, there's my west component, and here is my 3 meter long vector with a 35 degree angle. Okay, so let's find our y component here in north. So the way we find that is using SOHCAHTOA. SOHCAHTOA. Now remember, if we're going to use sine, we need the opposite angle over the hypotenuse. If we're going to use cosine, we need the adjacent over the hypotenuse. If we need tangent, we need the opposite over the adjacent. So here, in this case, to solve for the adjacent side, it's our x side here. Right? So the way I'm going to solve for that is using cosine. So cosine of 35 degrees is going to equal the adjacent side divided by my hypotenuse, and my hypotenuse is 3 meters. Okay, so if I solve this, I can multiply 3 to both sides. I get 3 cosine of 35. It's going to equal my adjacent. Alright, so go ahead and put that into your calculator. Now what you should have gotten is this number is going to get equal 2.46 rounded meters. Okay, now this again is our y component. Now in this case, this vector is facing north, right? So in order to get to this spot, this component faces straight up. So we're going to say that is north. Good. Alright, now let's find the x component. Finding the x component, I'm going to put it on this side. To find this, you can see this length is opposite of this angle. So what we would do, so here, we're going to use sine. So sine of 35 is going to equal the opposite over the hypotenuse, and the hypotenuse is 3. So multiply both sides by 3, multiply both sides by 3, you get 3 sine of 35 is equal to, now that equals 1.72 meters, and now this is going west. Okay, so here we just found both the x component, okay, and the y component. This we found out how much this vector had to rise, how much it had to go up north, and how much it had to go west in order to start here and end here. Okay, now we need to do the same thing for both vectors. So here, let's find out how long it has to take this vector to go down and how long it has to take it to go left, essentially. Now the way you do that is the same exact way we did up top. And so I'm going to go by through this a little bit quicker. So here is this side here is my adjacent side. So I'm going to use cosine. So 2 cosine 25 is going to equal my y component. And then for the x component, I have to use sine. So 2 sine of 25 equals my x component. Okay, so let's go ahead and solve those out. Put those into your calculators. Okay, so when you put that into your calculator, 2 cosine of 25, you should get 1.81 meters. Okay, now this is going south. Okay, now 2 sine of 25 is 0.85 meters, and this is going west. Okay, now the next thing that we have to do, okay, the next thing we have to do is we have to understand one thing. Okay, what they are asking us to do is to add these two vectors. Now we just broke down. We said in order to get to this spot here, from here, you have to travel 2.46 meters north and 1.72 meters west. That's how you get from here to here. That's our vector. Now, if we add another vector that goes 2 meters south and 25 degrees west in that direction, you have to travel 1.81 meters south and then 0.85 meters west. So if you were to take those two directions and add them, what you're really doing is, well, to get the total from where you started to where you ended, all you really need to walk is this much south and this much north. But instead of adding those two together, you just take the overall. So if you were to walk 0.65 meters north, you would get to the same spot that you would if you added these two vectors. Okay, and the same thing here, right? So here, you had to walk 1.72 meters west and also 0.85 meters west. So what you really, in total, you have to walk 2.57 meters west. Now you have two directions, right? Now you have these two vectors. Okay. Here you have your two ending, both what you have to walk up and down and what you have to walk left and right. So all we need now, right, just add up the total that you had to go north, add up the total that you had to go west, put those two together. So here, we start there, we go 0.65 meters north, and then from there we go 2.57 meters west, 0.65 meters north. Here is your resulting vector. All we have to do is, let's find the magnitude of that vector. So let's find this angle. Right? Let's find theta. What is that in degrees? And then let's find the magnitude. How many meters do we have to walk in that direction? The way we do that is adding parallel and perpendicular vectors. If we have perpendicular vectors, we use the Pythagorean theorem. A squared plus b squared. A squared plus b squared equals c squared. That's going to give you your magnitude. And tan inverse of the opposite over adjacent will give you theta. So from here on, you guys know how to do this, right? So you got 0.65 squared plus 2.57 squared is going to equal exactly the hypotenuse squared. Okay, so let's solve that. Okay, when you do that, 0.65 squared is 0.4225 plus 2.57 squared is 6.609, and that's going to be h squared. And that will equal h squared, and the hypotenuse squared. So 4.225 plus 7 plus 6.609 is going to equal 7.027. Now you take the square root of that, take the square root of 7.027, and you get, this equals 2.65 meters. Now your magnitude, okay, take that number and plug it in there, is 2.65. Now let's find that direction. Let's find the direction. Ignore that degree, it was not meant to be there. Okay, so finding the direction, all you have to do now is tan inverse that function of opposite, which is 2.57 divided by 0.65. That's going to give you theta. Okay, so let's try that into here. Okay, so 2.57 2.57. So tan inverse of 2.57 divided by 0.65, that is 75.8 degrees. So here, drawing this vector once more, this theta is 75.8 degrees. Alright, and we're almost done. All we need to do now is write out this vector in vector format. So our magnitude is 2.65, and now let's find our angle. So baseline is north. There's our baseline that's going up. So you're going north, you're going to go 75.8 degrees west of that line. And that's your final vector. This is your final answer. Alright, if you guys have any questions, just let me know in class.